Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to another session on Python for Excel users. In previous video, we discussed mm, we discussed creating a data frame in Python using a CSV file. Uh, we discussed how we can import a CSV file in Python or Jupyter Notebook. Uh, we discussed how we can create a data frame from a CSV file. Uh, then we saw the attributes of data frame. Uh, we saw how we can see a data frame in different ways. How we can use head method to see the first 5 rows by default and the number of specified rows using head method, and how we can see the last 5 rows by default using tail method, and number of desired rows is starting from last rows using the same tail method by specifying the number of desired rows inside the parenthesis after the head method and tail method both. Uh, then we discussed how we can we also saw that when we import a CSV file in Python or CSV data frame in Python, we are only able to see the first 5 rows and the last 5 rows of the data frame in Python. As we can see there, let me scroll. So when we import a CSV file or CSV or a data frame from a CSV file, we are only able to see our data frame in this manner, that is only first 5 rows and last 5 rows, and the rows between these first 5 and last 5 rows are hidden like this dotted lines. So we saw how we can see the entire table in Python, for which we have to define the parameter by using set option method. And before using that set option method, we have to uh, see the shape of our data frame or attribute of a data frame to determine the number of rows and columns, and the attribute is shape. So before setting option to see the entire table, we have to see the shape attribute of the data frame, and after seeing that, we will define the parameter to see the entire table by using set option method like this: PD for panda, giving a dot and using set option method, and display max rows after comma the number of maximum rows inside the data frame. When we define the parameter like this, we will be able to see the entire table in Python. As we can see here, we will just scroll down, and we have defined the parameter here. This is the row where we have defined the parameter, and after defining the parameter, uh, let me see, add a column, mm, add a new cell. After defining the parameter, when I type the name of the data frame and run this, I will see the entire data frame like this with a scroll down menu. So I can see all the rows of the data frame. So this was the set option method we discussed in last video, and then we proceeded with some attributes, functions, and methods in Python. And we saw how we can apply these attribute functions and methods to this CSV file. Uh, Attribute, we discussed what are attributes, columns, index, and shape. We use these attributes to see the results like this. columns index for rows, columns for column heads, and shape for number of rows and columns in table. Then functions, max function, mix function, len function. Max function, min function usually applies to integer, but when applied to our data frame, instead of showing the maximum and minimum value, it shows the function shows the name of the first column head, and max function shows the name of the last column head. Uh, and Max and min function cannot be applied directly to a column of a data frame, because a data frame is a data set and a column is a subset of that data set. So therefore, it cannot be applied to a specific column of a data frame directly, whether it contains integer, string, or any type of data. So, and then we use the length function to see the length of an attribute object, which can be a list, dictionary, or a data frame. So this was some functions we saw. Then we saw the methods: head method, tail method, upper, lower, and title method. We saw their examples, and after that, we established a rule of thumb that when we use method, we have to use parentheses after the method, and when we use attribute, or when we try to access an attribute of a data set or a data frame, we don't have to use parentheses after the name of the attribute. So this was the rule of the thumb. And after that, we discussed how we can select a specific columns of our data set or a data frame. Uh, there were different methods uh, uh, of selecting columns of a data frame. Uh, One method was just by using a dot after the name of the data set or a data frame, and then the name of the column which you want to get. But this method had a limitation that it cannot be applied to a column head which contains a special character or a space in its name. So dot method cannot be applied to such columns whose column head's name contains a space or a special character. So this was the limitation of dot method, or selecting a specific column of a data frame by using dot method. We also discussed how we can select a specific column of a data frame by using a square bracket method. And we also saw how we can select or call multiple columns of our data frame by using a square bracket. And to do so, we have to use double square bracket and enclose the name of the columns inside these double brackets separated by comma, as we can see there. So this was the content of the last video. Now we'll proceed with the same data frame, and we'll see how we can add new column in a data frame. So as we have already discussed how to select column using a square bracket method, so in the similar manner, we will be using the same square bracket method to add a new column in our data frame. So to do so, we will type the name of the data frame and just call an imaginary column which we want to add in our data frame, and give an equals to sign and the value we want to assign to that column. And this method basically gives a scalar value to the data to the new column which we want to add. So the scalar value, by saying scalar value, we mean to say that all the rows in that new column will have the same value. So let's come to the Jupyter notebook and see how we can add a new column by using a square bracket method. So as I said, to add a new column using a square bracket method, we will type the name of the data frame, and After the name of the data frame, we will use the square bracket method, and to add a new column, we will just call an imaginary column to add a new column, and use the name which we want to give to the new column. For example, if we want to add a column of art score, or scores of the student in the subject of art, so we will just call an imaginary column by the name art score, or let me say art underscore score, because I don't want to give a space in the name of the column. Uh, so we call the name and then assign it a value, which is which can be any value, let's say 60. So this method will assign a scalar value to the new column. So when I will run this, uh, what has happened? A new column has been added in the data frame and saved in the data frame. Uh, and all the rows in that column will have the value 60. So to check this, let's call the data frame by typing the name of the data frame and running this, and we can see the last column has been added, which is art score, art underscore score, and it has all the rows as 60 value. But in real scenario, it is not possible that all the students score the same marks in the uh, subject. So we have to assign this column a random value, which should be starting from 0. That is, the minimum value should be 0 and maximum value should be 100. And all the values or scores should be random number between these two numbers, or between this range, that is from 0 to 100. So to do so, we will have to use NumPy library, uh, and we will have to see the shape of the data frame before proceeding with that. Shape attribute to see the number of maximum rows and number of columns in the data frame. Now, since previously the shape attribute gave me 1,000 rows and 8 columns, if I scroll up, I can see here it gave me 1,000 rows. That is the number of rows, and number of columns are 8. But now when I will see the same attribute, it should give me 1,000 rows and 9 columns, because I have added a new column of art score in this data frame. So let's copy and run this. Now I can see that the data frame has 1,000 rows and 9 columns. So we have got the shape of the data frame, and now I will be using NumPy library to give the column of art score random values between 0 and 100. So what should I do? Uh, Before doing so, one has to import NumPy library. But I have already imported NumPy libraries in my previous videos. If I scroll up to see that, we can see that we have already imported NumPy library here. Import NumPy as NP. So NP stands for NumPy. So the library has already been imported there. So I will not be needing to import it again in order to uh, perform the desired function, that is assigning the art column random values between 0 to 100. So to assign random values between 0 to 100, I will use NumPy array, and to do so, I will be using arrange method. So let's see how we can do this. So what we will be doing here, we will be using NumPy array or NumPy library to create an array of 1000 elements, which will be containing values starting from 0 to 100, and we will be using arrange function to create the array. And to do so, we will be using np for numpy dot arrange function. Let me check the spelling of the function arrange, and arrange function 0 to 1000. So here we will be creating an array, and when we will run this, we will get an array of 1000 elements containing values. Sorry, this array is containing values from 0 to 1000. Uh, and to check whether the array has 1000 values, we will use len function to check this, and we will just copy the array which we have just created and enclose this inside the len function. And we run this, we will be confirmed that the array has 1000 values or 1000 elements. So in this step, uh, we have created an array of 1000 elements containing values from 0 to 1000 and not between 0 to 100. And we will name this array as art score. Like we will use art space score is equals to and the array. And when we will run this, there is a space. So due to space, I was getting an error. When I run this, I have got art score, and this array has been saved in this uh, variable, which is art score. And now I will use the same square bracket method to add a new column again by this name, and assign the value of this variable to that column, just as we did previously above. In this method, we assigned a scalar value to this column, but now we have created an array and name that array as art score. And now I will assign that array to this variable. So instead of 60, I will be using the name of the array, which is art score without space. This is the name of the array which just I have given here. So I will copy the same function or syntax from above to create a new column by using the square bracket method. But there we assigned a scalar value to that new column. But now I will be assigning it the variable art score, which is an array of values is starting from 0 to 1000, not 100. So when I will run this, this has been saved, and now when I will call the data set, I should be getting the column, new column. So here the new column, and now this column does not have same values for all rows, but the values are starting from 0, and these are 1000 values and ending at 999. So in this method, what we did, we created an array of 1000 values starting from 0 to 999, gave it a variable name, and then use the same square bracket method to call an imaginary column with the desired name and assigned the value which I saved in this array. So in this method, we added a new column containing values from 0 to 1000. In this way, this table does not have any scalar value but different value, but still in real world scenario we need the values starting from 0 to 1000. No, sorry, 200, because the maximum score is 100. So the values should be between 0 to 100, and the arrow should be of 1000 values containing numbers between 0 to 100. So what should we do to perform this function? Beside beside being values, beside these values are starting from 0 and ending at 999. We can also see that all the rows cannot have values in sequential range or sequential manner. These values should be random values starting from 0 to 100, and these should be 1000 values. So we will again use the same NumPy library, and we will create a NumPy array, but this time we will add an argument, that is, we will be instructing it to generate 1000 values or 1000 numbers containing values between 0 and 100 in a random manner. So to do so, what we will do, we will use a method random.rand integer or randit. So let's see. What we'll be doing, we will again be using NumPy libraries to generate random numbers, and that random numbers should be integer starting from 0 ending at 100, and the size of that array should be of 1000 elements. So this will be the syntax which we will be using, and after creating this array we will again save this array in a variable, uh, and then once this array is saved in a variable, we will again use a square bracket method to call an imaginary column and assigning this new variable as a value of that column. So let's see. Uh, let's again use the NumPy library, np for NumPy dot random, to create random number. Then what we want to create, we want to create random integer. So for random integer, use rand int, and then open parenthesis, and the value of these random numbers should be between 0 to 100, and the size of the array should be of 1000 elements. So size is equals to 1000. Now when we run this, we will get random numbers starting from 0 ending at 100, and these random numbers will be comprising of 1000 elements, or the size of this array will be of 1000 elements. Now name this array again as art score, and this time let's name it as art star. No, let's name it as art score as capital and use double E in the end to differentiate it from the previous name which we used here. So I used double E for score. So I have named this array again as art score with double E to differentiate it from the previous list or previous array. When I run this, it has been stored in this variable. And now I will again be using the same square bracket method to create a new column. I will copy this syntax again. That is the name of the data frame inside the square bracket, the name of the imaginary column which I want to add, and after that the name of the array which I just created with values starting from 0 ending at 100, and the number of elements of this array should be 1000 elements. So I just add an E after that, art score with double E, and when I will run this, I saved this data frame, that is a new column has been added with this value. And now when I will type the name of the data frame, that is student's performance, I should get the new column added with random values. And now this time neither these values are a scalar value, that is same value in all rows, neither these values are starting from 0 and ending at 999, but these values are between 0 to 100, and these are 1000 values or 1000 elements. So I fulfilled the purpose and I generated a new column or added a new column for art score containing values between 0 and 100, and these values are, and the size of these values are 1000. So this was the method to add new column in our data frame. First, we added new column using a square bracket method with a scalar value. Then we uses NumPy library to generate a list of 1000 values starting from 0 to 1000. But that was also not a real world scenario. The values should have been between 0, that is the minimum score is 0, and the maximum score is 1000. The values should have been between 0 to 1000. So again, we use a NumPy library to generate random numbers between 0 to 100, and generate an array of 1000 values or 1000 numbers whose values are between 0 to 100. So this was our purpose. So we achieved the purpose by using a square bracket method and NumPy library. So as we have created an array of 100 values uh, between 0 to 100, 1000 values, basically 1000 values containing values from 0 to 100. We can also create a list of random float numbers. Here we have generated integers. We can also create an array of float numbers in the same manner. Uh, but in that case, we will be using the same NumPy library and random method. and instead of rand int command, we will be using uniform command. And so we used NumPy library random method, but this time instead of random integer, we used uniform command to generate a list of 1,000 values containing numbers between 0 and 100. When we will run this, we will get a list of floats this way. So this was the method to generate random float number of any size ranging from 0 to 100 or any number. So this was the method to create an array of float numbers. So that's how we learned how we can add a new column in a data frame using a square bracket method and using NumPy library to generate a list of numbers and then assign that list to the new column of the data frame. So this was the method to create to add a new column. Now let's see some functions or operations that we can perform in data frame. So we can perform math function or math operations in data frame. For example, if we want to add a column of total numbers or total marks obtained by a student, so we can perform some function, and in that case again, as we just saw how we can add a new column in the data frame, we will be adding a new column with the name total marks. In the same manner, we added the r_score column. That is, we will be using a square bracket method to create a new column. So let's see. So here we have a few math operations that we can apply on different columns and rows of the data frame. But let's see, let's first see how we can apply math operation to the columns of the data frame. There are some function, count function, mean function, standard deviation function, minimum and maximum function, and how these are applied. We give the name of the data frame, type the name of the data frame, then inside the square bracket we type the name of the column whose sum we want to get, or the name of the column on which we want to perform the specified math operation, and that operation can be sum, that operation can be count, that can be mean, that can be standard deviation, that can be max function, that can be min operation. So the sum will give me the sum of the column, count will give me the number of values in that column, mean will give me the mean of the values of that column, standard deviation will give me the standard deviation of the values of that column, and maximum and minimum, that is max and min, will give me the maximum and minimum value of the specified column. So let's quickly see how we can apply these maths operation to the desired column. Let's see, I want to apply uh, these operations on reading score column. So what will I do? I will type the name of the data frame on which I want to apply the math function. Sorry, I did not copy the name of the data frame. So I will go back again and copy the name of the data frame and paste it. Sorry, not copy it again. Let me select this again and copy this. And now this time this should work. So I paste the name of the data frame and then I will give a square bracket or use a square bracket, and inside a square bracket I will type the name of the column on which I want to perform the math function. So I will copy the name of the column, that is reading score, and inside a square bracket I will type the name of the column on which I want to perform the function, and then I will type the function. When I will run this, okay, the name of the column should be inside quotes. Now this should give the value. So this is the sum of the reading score column. Similarly, if I want to get the number of values in this column, I will type the same syntax, and instead of sum I will type the count operation, and this column has 1000 values or 1000 elements. So count function can also be applied to the data frame straightforward. Just paste or type the name of the data frame and give a dot and then type count, and when I will do this it will give me the name of all the column heads and the number of values in each column. So count function, this time instead of a single column I have applied the count function to the entire data frame, and this has given me the result in this manner, that is the name of all the columns and the number of values in each column and the data type of each column. So count operation can be applied to the entire data frame. Now let's see other function. Let me copy the syntax again. For this specific column, I can also get the mean of the values in this column by using mean function or mean operation. So this is the mean of the values. I can also get a standard deviation by using std operation. When I run this, I will get the standard deviation of the values in this column. So these are some math operation that can be applied on it, and I can also get the minimum value of this column by using min operation. So the minimum value is 17, and I can also get the maximum value in this column by using max operation, and the maximum value in this column is 100. So these are some math operations that can be applied to the columns of the data frame, and these functions can also be applied to the rows of the data frame. And how can these be applied? To do so, we will have to add a new column and then perform that function on that new column to get the desired operation performed. So how we can do that? Let's see. We can sum the columns, and what will we will be doing there? We will be basically applying these operations to the uh, rows of the column. So we can simply perform these functions just by using the operator sign between the names of the column. Let me add some new cells before proceeding. So if you want to get the sum of columns or sum of values in rows, uh, let me first have all the columns which have integer values, because math operation can only be applied to those columns which have integer value. So in order to just get the those columns which have integer values, there is uh, a method which is describe method, which will give me some basic statistical data of all the columns which have integer values. So let's do this. For getting this done, we will be typing the name of the data frame and using the describe method, and this describe method will give me some statistical data of those columns which have integer values. So integer or float values. So these are the columns which contains only numerical data, that is integer or float. Now let's sum these columns uh, or sum the values in each rows of these columns. So what we will be doing here, we will be typing the name of the data frame, that is data students performance. We will be using a square bracket method just as we used to select a column, and we will be typing the name of the column inside the square bracket, and the name should be enclosed in quotes, whether single quote or double quote. So that's how we will be calling the specific column. So now what if we want to sum uh, these columns? What we'll be using? We will be just using the plus sign and again repeating the entire uh, syntax, that is name of the data frame, and now inside the square bracket we will be giving the name of the second column, which is reading score. Then again we will use the plus sign and we will copy the entire syntax again, that is the name of the data frame, and inside a square bracket the name of the third column, and which will be writing score. Then again give us plus sign and again the entire syntax, that is the name of the data frame, and inside a square bracket the name of the fourth column, which is art score. Now when I run this, I will get the sum of each rows. That is, all the columns in that row are summed up. Now, what if we want to add a new column of total score to show the total of each column? To do so, we will still be using the same square bracket method to call an imaginary column uh, with the name uh, total score. But before doing so, let's save this sum that we have just performed with the name total score. Let's say total underscore is score. So what I have done here, I have saved the sum of each column in this variable which is named as total score, and when I will copy this variable and run this, it will give me the total score. And now I will be creating a new column using the same square bracket method. That is the name of the data frame and the name of the imaginary column which I want to get, and that will be total score, and assign this column a value which is saved in this variable, which is the sum of all the columns. So what I have done here, uh, I have added a new column in the data frame with the name total score and assigned it a value which is a variable, and that variable contains the total of all the rows. And now when I will run this, a new column will be saved in the data frame. And to check this, I will type the name of the data frame and run it. Sorry. Uh, let me copy this again. Copy the name of the data frame, paste it, and run this. And now when I will run this, I will get a new column added with the name total score and the total of each row in this column. Total of all columns have been totaled in this column, and this sum is raw wise sum, that is math score, reading score, writing score, art score. So basically this is a row and this is the sum of the row, and this column is showing me the sum of basically all the columns in this column, and the sum is row wise sum. So that's how we added a new column with total score. We can also get average of the column, uh, and to do so, let's go back to this step, and now we are trying to add a new column with the which should show the average of each row, or average score uh, obtained by each student. So I will copy the syntax to add all the values or all the columns, that is data frame, name of the column, then again data frame, name of the column, then again data frame, name of the column. So all the columns are added, and now I will be dividing the entire syntax with the number of columns I have added. So here I have added math score, reading score, writing score, and art score. That is, there are 4 columns I have added. So I will be dividing this entire uh, syntax with the number of columns added, and enclosing this entire syntax inside parentheses, and dividing it by number of columns which I have added, that is 4. And now when I will run this, I will get the average of each row, average score of each student. So now again, I will save this in a new variable and will name it as average underscore score. When I run this, this has been saved in this variable, and again I can add a new column to show the average of each student. Let me check it first. So it has been saved, and now let's add a new column in the data frame, and name of the data frame, the name of the new column which I will be uh, I want to add. So name of the data frame, and the imaginary column will be named as average score, which I want to add, and then assign this column with a value which I have just stored in this variable, which is named as average score. And when I will run this, it has been saved in the data frame. That is, a new column has been added with this name, and this column contains the average of all students, average score of all students. And to check this, I will copy and paste the name of the data frame and run this. And when I run this, I will get the new column added, that is average score. And here I can get the average score of all the students. So here I got the average score of all the students. So uh, I can also perform if uh, if I am getting these numbers uh, integer values, if I am getting integer values which are extended to more than 2 decimal places, then I can also use round function to a specific column or even to the entire data frame to get the values rounded up to the number of desired decimal places, which is often 2 decimal places. So let's see how we can do this. We can just use round method to the entire data frame. That is, copy the name of the data frame, give a dot, and use the round method. That is RUND round. And inside the parentheses, I will give the number of decimal places to which I want to round off the float value. And when I will run this, I will get the values rounded up to 2 decimal places. Since it was already rounded up to 2 decimal places, so I cannot see any difference there. But if there had been float values extended to more than 2 decimal places, it would have been rounded up to 2 decimal places. So this was the method to round off any float value up to 2 decimal places. So that's all for today. I hope this video would have been interesting for you. Thank you for watching. Allah Hafiz.